It's Tuesday again and I would like to hang with you lads, but I'm off to listen to the new episode of the Slaven Selection Show. Play now or stay in dark forever.
Mesdames et messieurs, this is a very special episode for me. I can't believe it's already the 25th episode. And it's beautiful outside. 25 Celsius in Toronto. Synchronicity everywhere. Everything began in January, not March, because I was initially with Spotify only and later on with Buzzsprout, who got something wrong with my podcasting history. So, nevertheless, it's been 7 months now, and by the following January it will be nearly 50 episodes. So, as I previously stated, everything began while I was still recovering from the accident and studying for my IT certifications. I've learned a lot, yet I still don't feel like I know anything. My main issue is audio quality, which I plan to improve once I relocate at the end of the year. When it comes to podcasting, I've heard a lot of advice, especially on how to monetize your efforts. Whoever is attempting this for money or glory only will probably fail. Me personally, I genuinely enjoy what I do. If the money arrives, that's fantastic. If not, I'll still do it. So happy 25th to me. Also, thank you, Stephen and Alex, and you have helped me a lot. Anyways, here's a piece of fiction for a start. It is from Vacuum Diagrams, a story from Xili Sequence series by Stephen Baxter. Jack Raoul, we believe we have found a way to construct soliton stars, stellar mass objects of dark matter. Such is the purpose of the experiment conducted here. We will build the first dark matter stars, the first in universe history. Well, Snolab is not creating dark matter stars, at least not yet. I went to Canada in 2012, the same year that Snolab started operating. Synchronicities again, right? We all enjoy coincidences, don't we? Despite how ridiculous they might be, they offer an air of importance. Ontario Science Centre, which opened in 1969, so it's my age, again, synchronicity, and was one of the first interactive science museums in the world, pioneering an interactive approach adopted globally. Open as a centennial project and now permanently closed to the public on June 21st, 2024 due to concerns about the structural integrity of the building's roof. Of course, leaking roof is an excuse, and just like many people claim, it looks more like a hostile real estate takeover than anything else. No big surprise, Toronto is currently considered as North America's fastest growing city, according to a recent analysis by Toronto Metropolitan University, better known as Ryerson. Yes, I said it, so what? It will always be Ryerson to me. Toronto's population expanded by 125,000 people between July of 2022 and July of 23, making it the fastest growing metropolis in both Canada and the United States. Toronto's metropolitan region experienced even more growth, gaining 220,000 people during the same period, outperforming big U.S. cities like Houston and Dallas. So why do you even ask why they shut down Ontario Science Centre? Do you remember Richmond Hill Observatory? Oh well. Snolab's work has been exhibited at the Ontario Science Centre. More specifically, Science North created the New Eyes on the Universe exhibition on behalf of Snolab, which was on display at the Ontario Science Centre. Snolab was able to communicate its award-winning research and continuing experiments with the public through the Ontario Science Centre exhibition. And this exhibition was a shining example of how collaboration in Canadian research and outreach leads to success, according to Dr. Smith, director of Snolab. a presentation of the Nobel Medal and pictures from the 2015 Nobel Week in Stockholm, where Dr. Arthur MacDonald was awarded Nobel Prize in Physics for his work on Snolab, were also featured in the show. Both organizations are dedicated to encouraging public participation in research and education. While Snolab hopes to share its groundbreaking research with the public through these kinds of exhibitions, the Ontario Science Centre aspires to ignite a passion for discovery. OCC is no more, so now you have two options. Either you will enjoy Snolab content online or travel straight north. It's still summer, so hurry up, it can't be that bad. In the cold northern Ontario, there is a facility not too far from mining town Sudbury. There are more centers for research on dark matter and neutrinos outside Snolab. And these include the Kavli Institute for Cosmological Physics, CPRC Center of Excellence for Dark Matter Particle Physics, University of Washington Dark Universe Science Center, of course famous CERN, Fermilab, then Laboratoire Souterrain des Mondains, and so on. However, I'm willing to claim that Snolab is among the greatest. So what does it stand for? Snolab stands for the Sudbury Neutrino Observatory Laboratory. The relevance of Snolab to the scientific community is underscored by its growth from the initial experiment done at Sudbury Neutrino Observatory and Dr. Arthur MacDonald's 2015 Nobel Prize in Physics for his contributions to the SNO experiment. Its role as an essential MacDonald Institute partner located at Queen's University in Canada is to act as a national center for astroparticle research. And Queen's doesn't not require much introduction. As they say, Queen's kicks ass. The MacDonald Institute receives major financing, including $63 million award from the Canada First Research Excellence Fund. Its mission is to position Canada as a global leader in astroparticle physics while encouraging scientific collaboration and discovery. And all of that is promoting collaboration and giving the next generation of scientists opportunities for scientific training. Snolab's continued global attraction of scientists and projects underscores its position as a global leader in underground science research. So, the most elusive and mysterious thing in the universe, something that inspires difficult to understand and non-scientifically fictitious productions like Stranger Things and Dark, as well as the imaginations of all of us mortals, might still be unattainable, but we're working on it. So what do we know so far? Well, dark matter is a hypothesized type of matter that accounts for approximately 27% of the universe's mass energy content but does not emit, absorb, or reflect light, rendering it invisible and only detachable through gravitational effects. Here are the main characteristics of dark matter. Dark matter does not emit, absorb, or reflect light. Therefore, is fully invisible to electromagnetic waves. Because of the lack of interaction with light, it cannot be identified using normal methods for studying regular matter. Instead, its existence is derived from gravitational impacts on visible matter such as the motion of galaxies and galaxy clusters. Despite being invisible, dark matter has gravitational forces. It is critical to galaxies' creation and structure. Observations reveal that the gravitational forces of dark matter are necessary to explain the rotation curves of galaxies. Stars near the fringes of galaxies move at speeds that cannot be accounted for by visible stuff alone. There's many more, but this is about Snolab. I will discuss dark matter some other time. Sudbury is hardly Pine Gap, Wayward Pines, or Twin Peaks, but it does have a certain mystery due to Snolab. James Worthington, the superintendent of construction on the Northern Ontario leg of the railway, chose the name Sudbury after Sudbury, Suffolk, England, which was the hometown of his wife, Caroline Hitchcock. Snolab is located on the outskirts of Lively, close to Meadbird Lake and Sudbury, 2 kilometers below the surface in Valley Crichton, one of 113 mines, I hope I counted right, in Ontario. Lively is a community in Ontario, Canada that serves as the administrative and economic center for the greater Sudbury area. It was founded in the 1950s as a company town for employees of Inco's Craton Mine and named for an early settler, Charles Lively. The village was part of the previous town of Walden, which was abolished in 2001 when Greater Sudbury was formed. Funny thing is that the access to the underground facilities is provided via the nearby mine elevator operated by Brazilian mining company Vale Ltd. How the Brazilians got their hands on the Canadian mine is not for this episode. Long story, as they say. With 166,000 residents as of the Canadian census of 2021, Sudbury is the most populous city in Northern Ontario. It spans a varied terrain of urban regions and natural settings, including around 330 lakes, making it the largest city by land area in Ontario and the 5th largest in Canada. Before European settlers arrived, the Ojibwe people lived in the area for thousands of years. When nickel and copper ore were discovered in 1883, while building the Canadian Pacific Railway, Sudbury became a mining center and its modern history began. The deepest operable clean room facility in the world is called Snolab. The laboratory itself is kept as a Class 2000 clean room with extremely low levels of dust and background radiation while being accessible through an operating mine. The overburdened rock that covers Snolab's 2,070 meters offers 6,010 meters water equivalent MWE of shielding from cosmic rays, making it an ideal low background setting for experiments that demand high sensitivity and extremely low counting rates. Snolab provides an incredibly deep and clean environment that makes it possible to study weak processes and highly unusual interactions. Apart from dark matter and neutrino physics, biological studies are conducted in an underground setting at Snolab as well. The Homestake experiment in South Dakota and other earlier experiments had only identified roughly 1/3 of the expected solar neutrinos, and this led to the solar neutrino problem, which the SNO experiment set out to resolve in 1998. Since SNO was built to detect all 3 flavors of neutrinos, it was confirmed that while the sun produced the predicted amount of neutrinos, their flavor changed on the way to Earth. Because of their groundbreaking research, Dr. Takaki Kajita of Super Kamiokande in Japan and Dr. Arthur MacDonald of SNO were granted the 2015 Nobel Prize in Physics. Plans for an expansion to form Snolab were started while SNO was gathering data. Construction on the proposal, which was suggested by a number of Canadian universities, including Queen's, Carleton, and Laurentian, started in 2004. Building on the SNO infrastructure already in place and adding a sizable amount of laboratory space, including clean room facilities, Snolab fully launched in 2012. Snolab hosts several cutting-edge experiments, including SNO plus a neutrino experiment using liquid scintillator to detect various types of neutrinos. Then there is HALO, a neutron detector for observing neutrinos from supernovae. Then Deep 3600, a dark matter detector using liquid argon. Then PICO 40L, a bubble chamber experiment searching for dark matter. Then Super CDMS, a cryogenic dark matter detector under construction. Probably the lab's greatest accomplishment is the SNO experiment which was intended to address the solar neutrino problem, which had perplexed scientists since the Homestake experiment in the 1970s. This issue developed when prior experiments found just approximately one-third of the expected solar neutrinos. SNO was specifically built to detect all three types of neutrinos: electron, muon, and tau, unlike prior experiments that could only detect electron neutrinos. The experiment verified that the Sun produced by the expected number of neutrinos, but that these neutrinos were changing flavor or oscillating as they traveled to Earth. And this discovery established concrete evidence for neutrino oscillation and demonstrated that neutrinos have mass. This breakthrough not only resolved the long-standing riddle in particle physics, but it also has far-reaching consequences for our understanding of the standard model of particle physics and the nature of matter in the universe. It established Snolab as a world-class subterranean science facility, paving the stage for future investigations in neutrino physics and dark matter discovery. So, what is neutrino anyway? It's a basic subatomic particle known as neutrino, which is electrically neutral and has a very modest mass that was long believed to be insignificant. The lepton family of particles, which also contains taus, muons, and electrons, includes neutrinos. Their primary means of interaction are gravity and the weak nuclear force, which makes them incredibly elusive and challenging to find. Neutrinos have weak interactions with matter, making them difficult to detect. Neutrinos are observed using large detectors, usually buried to reduce influence from cosmic rays. The exact masses of neutrinos, the phenomenon of neutrino oscillation, where neutrinos change from one flavor to another, and whether neutrinos are their own antiparticles, are among the topics of continuing research in neutrino physics. The most prevalent large particles in the universe, neutrinos, are essential to our comprehension of cosmology, basic physics, and matter's behavior. Their research has consequences for ideas about dark matter, the early cosmos, and the basic forces of existence. Neutrinos, often known as ghostly chameleons, are among the most elusive particles in the cosmos, and their behavior has required in a number of baffling problems in particle physics. And these puzzles mostly concern neutrino oscillation and the possible existence of additional but undiscovered forms of neutrinos. The study of neutrinos is at the forefront of modern physics, with continuing experiments and theoretical discoveries aimed at solving its riddles. As researchers continue to investigate the anomalies and potential new physics surrounding neutrinos, the quest to explain these elusive particles remains a fascinating and complicated task in particle physics. Still, not everything in Snolab is about neutrinos or dark matter. As I have said, the laboratory also conducts other research and experiments. Fruit flies are used in the flame or flies in a mine experiment study to look into the biological reactions of the subterranean environment to elevated air pressure. Using a variety of biological models, repair or researching the impact of the presence and absence of ionizing radiation, investigates the impact of low-level natural background radiation on cellular repair mechanism, growth, and development. In addition, Snolab is investigating geology and quantum computing projects, making use of its distinct subterranean environment to support a variety of scientific investigations that extends beyond particle physics. The facility is the perfect place for research requiring low background influence from cosmic rays and other environmental conditions because of its depth and cleanliness. Also, from what I heard from Sudburians I know, there is not much to do over there. The winters are quite unpleasant, they say. Could be, but I bet 2 kilometers underground is better. In continental crust, the average geothermal gradient is between 25 and 30 Celsius per kilometer. It is normal for underground facilities at this depth to have temperatures between 10 and 15 Celsius, if I got it right. Maybe not as toasty as Turks and Caicos, but certainly not as bad as minus 20 plus wind chill factor in the winter on the outside. I also have a sneaky suspicion that the entertainment in Sudbury in wintertime is comparable to that in Fort McMurray, if you know what I mean. There are various ways to experience and learn about Snolab, even if it's not open to the general public for visits. Snolab provides a virtual tour experience that lets you use VR goggles or your PC or mobile device to explore the facility. Nobel laureate Dr. Art McDonald is available for a guided virtual tour during which you can visit facilities and experiments and pick up knowledge. Space Place, the fourth level of Scientific North, the scientific museum in Sudbury, features Snolab-related displays. You can take a virtual 360 tour of the facility, examine a model of Snolab, and see real-time particle trails in cloud chamber. Between the Stars Theater experience featuring Snolab-related artifacts and spectacular effects is also available at the museum. And if you ever decide to go visit Snolab, don't forget to warm yourself up with dark matter coffee. All Raw Coffee Roaster in the area offers a unique blend called Dark Matter Coffee, which draws inspiration from Snolab research. This distinctive branding introduces the scientific community to Sudbury's everyday life and sparks conversation among both residents and tourists. Proudly roasted in Northern Ontario on the ancestral grounds of the Atikameksheng Anikashwabek. I'm sorry, guys. I know I didn't pronounce it right. I apologize. In accordance with the Robinson-Huron Treaty of 1850 and influenced by California. So, in any case, as I have said, summer is still here. If you don't want to watch stars, go visit Snolab Museum. And again, this was a 25th episode. I'm very happy about it. More are coming. And until the next time, guys, stay selective. Bye-bye.